Up to the last clipping, we learned that in Ohm's law, considering a conductor, if there are 2 points considered as A and B and the potentials as VA and VB, and if we assume that VA is greater than VB, then we know potential is the energy and the energy at A is higher than the energy at B. So when these 2 points are joined, then the current flows from A towards B, and the rate of flow of charge or the rate of current will be greater if this difference in energy is greater. And this is stated in this law when temperature and other physical factors like temperature, length, cross section, material of the conductor, all these elements, all these factors of the conductor, if remain same, constant, then according to Ohm, the rate of flow of current is directly proportional, or the rate of flow of charge, the current directly proportional to this difference in potentials, difference in energy. Suppose 2 containers are there connected by connecting tube, and the level of water is higher in this first container and the level is lower in the second container. If we open the connecting tube, then water starts flowing from first container towards second container until the levels of the water become same. So that means when the potential, there is a difference between potentials between 2 points of a conductor, then a current flows from higher energy level or higher potential point towards lower potential point. And according to him, symbolically, VA minus VB is proportional, directly proportional to the current. That means যদি এই ডিফারেন্সটা গ্রেটার হয়, কারেন্ট গ্রেটার হবে, কারেন্ট গ্রেটার ফ্লো করবে। এখানে যদি লেভেলের ডিফারেন্সটা বেশি হয় তাহলে হায়ার রেটে ওয়াটার ফ্লো করবে। যদি ডিফারেন্সটা কম হয়, লেভেলের মধ্যে ডিফারেন্স যদি কম হয় তাহলে কম ওয়াটার ফ্লো করবে। If this difference is assumed as single V, we know in mathematics when the variation sign, the proportional sign is replaced by an equal sign, then the second quantity is to be multiplied or divided by such a quantity which always remains constant. That is called constant of proportionality. Here the constant is R, and this R is called resistance. What is resistance? Previously we have learned that in a conductor there are large number of free electrons, and those free electrons are responsible for the flow of current. But when those free electrons start traveling, they are obstructed by the constituting atoms of the conductor. এখানে যে কন্ডাক্টরের যে অ্যাটমস গুলো আছে, এদের গ্যাপ দিয়ে ইলেকট্রনস গুলোকে মুভ করতে হচ্ছে। So these atoms try to obstruct the motion of the free electrons, and that obstruction is called resistance. This is the obstruction applied by the material atoms of the conductor against the flow of free electrons. From this expression we can write R is equal to V by I. That means it is the ratio of the potential difference applied আমরা যেরকম ডিফারেন্স রাখবো তেমন কারেন্ট পাবো। দ্যাট মিনস যে পোটেনশিয়াল ডিফারেন্স অ্যাট এ সার্টেন ইনস্ট্যান্ট অফ টাইম অ্যাপ্লাই করা হয়েছে, অ্যান্ড আন্ডার দ্যাট সিচুয়েশন যে কারেন্ট ফ্লো করছে, আমরা যদি হায়ার ডিফারেন্স রাখি তাহলে হায়ার কারেন্ট ফ্লো করবে, লোয়ার ডিফারেন্স রাখলে লোয়ার কারেন্ট ফ্লো করবে। যে ডিফারেন্স অফ পোটেনশিয়াল রাখা হয়েছে অ্যান্ড তার জন্য যে কারেন্ট ফ্লো করছে, the ratio of these two is called resistance. Its symbol is already seen as capital R and its unit is ohm, after the name of the scientist, ohm. So 1 ohm is equal to 1 volt by 1 ampere. That means if we maintain a potential difference of 1 volt between these 2 points, and under that situation, if 1 ampere of current flows through the conductor, then we have to understand that the resistance of the conductor is 1 ohm. On which factor this resistance depends? The factors affecting are, which are the factors that may affect the value of our temperature? When we are discussing about temperature for normal conductor, that means all the metallic conductors, resistance is directly proportional to the temperature of the material. তো আমরা যখন একটা কন্ডাক্টরের ভিতর দিয়ে ফ্রি ইলেকট্রনস গুলো ট্রাই টু মুভ, এদেরকে অবস্ট্রাক্ট করছে, এদের যে নেবারিং অ্যাটমস গুলো আছে অফ দ্য মেটেরিয়াল, সেই অ্যাটমস গুলো ওদের অবস্ট্রাক্ট করার চেষ্টা করছে, এদের মুভমেন্টটাকে অবস্ট্রাক্ট করার চেষ্টা করছে। They try to resist the movement of the free electrons, and when we increase the temperature of the material of the conductor, then those atoms which try to obstruct the motion, those atoms get excited more and start vibrating more and more, and when they start vibrating more vigorously, they try to sandwich the free electrons between them more, so the obstruction will also more. For semiconductors, these are certain materials like silicon, germanium, etc. These typically shows certain peculiar property up to a certain temperature. They cannot produce enough free electrons, so they behave like bad conductors. Because we know the free electrons are responsible for current. So which material can produce more free electrons? They will act as better conductor. But up to a certain temperature, these materials cannot produce enough free electrons. So up to that temperature, they behave like bad conductors or insulators. And that temperature varies from material to material. If you take silicon, the temperature of that critical temperature, that specific temperature is certain degree Celsius or certain Kelvin. But if you take germanium, that specific temperature is different from silicon. and beyond that temperature, when you increase the temperature beyond that limit, they start producing more and more free electrons. That means as temperature becomes higher and higher, that specific temperature reach করার পর আরো ফার্দার যখন টেম্পারেচার রাইজ করবে, they start producing more and more free electrons. That means they start behaving better and better conductor. So that means up to a certain temperature they behave like insulators. Beyond that temperature they start behaving as conductors. And number 3, for certain alloys like constant 10, manganese. For these alloys, temperature, when you increase or decrease, resistance remains unchanged. For varying temperature. That means the temperature has almost no effect on the resistance for these alloys. If we make a graph of current against potential difference, then for ohmic conductors, means the conductors or the materials which follow Ohm's law, for them this ratio is constant. The R, this is constant. That means it never varies. That means when you increase potential difference, current will increase. When you further increase the potential difference by same amount, the current will increase by same amount. That means the two factors will proportionally increase each other. So they are called ohmic conductors. For example, all the metallic conductors. But when it is the case of semiconductors like silicon or germanium, up to a certain temperature, you increase a potential difference very high, but you cannot get enough current, because up to a certain temperature they cannot produce enough number of free electrons. So their current is very low in spite of the fact that the potential difference applied is very high. So y-axis, the value of y-axis is very high, but the value of x-axis is very low. That means the graph is like this. But after that, it starts moving this way. Semiconductors. And in the case of alloys, certain alloys, it has a certain value of resistance, and that value almost remains same. Alloys. These two are called non-ohmic conductors because they do not follow Ohm's law. In varying temperature, they behave peculiarly. But these metallic conductors are called ohmic conductors because they strictly follow the Ohm's law. Their resistance always remains constant. This is the topic, how temperature affects resistance. Also, resistance depends on the length of the conductor and on the cross section of the conductor. A. Suppose there is a very short pipe which is being used to flow water from tap to bucket. If the pipe is very short, then we can see that the flow of water is very high. Large volume of water flows out per second. But if the pipe is made very very long, suppose প্রথমে আমরা 1 মিটার লং পাইপ নিয়েছিলাম, সেখানে যে ভলিউম অফ ওয়াটার ফ্লো আউট করছিল 1 মিটারের জায়গায় আমি সাপোজ 30 মিটারস লং একটা পাইপ নিলাম, তখন দেখব যে the flow of water per second, the volume of that water becomes very low. That means as the length of the pipe is longer, the length of the wall of the pipe is also longer, and the pipe's wall obstructs the flow of water. When the water starts flowing through it, the water molecules a friction is applied by the wall against the flow of water. So as the wall is longer, the friction is more. That means the obstruction or resistance is also more. So resistance is directly proportional to the length of the conductor. Now let's consider a narrow tube. When the tube is narrow, in 1 second the total volume of water coming out is very small, but if the pipe is thicker, then a larger volume of water gets out. That means when larger volume of water gets out for a thicker tube, that means the obstruction is less. So when there is a bigger cross section, resistance is low, flow is more, and when there is a smaller cross section, the resistance is high and flow is less. So it is inversely proportional to the cross sectional area. Combining these two, so R is equal to some constant should come here, because the proportional sign is replaced by equal sign. That constant is called rho. From this, rho is equal to R into A rho is equal to RA by L. So if you put A is equal to 1 and L is equal to 1, you get rho is equal to R. That means if you take a conductor whose cross section is unit cross section means if you take in SI system, the cross section is 1 square meter, and if you take that conductor whose length is unit, that means its length is 1 meter. Let me show inside the conductor. Suppose this is a conductor, and if you consider a cubical piece of that conductor, আমরা যদি ওর থেকে একটা কিউবিক্যাল টুকরো কেটে নিই, ওই কন্ডাক্টরের থেকে যদি একটা কিউবিক্যাল টুকরো কেটে নিই, এবারে ওই কন্ডাক্টরের ভেতর দিয়ে কারা ফ্লো করছে? ফ্রি ইলেকট্রনসরা ফ্লো করছে। all the free electrons flow. So all those free electrons have to travel through this cubical part also. এই কিউবিক্যাল পার্টের এই যে ওয়ালটা আছে, এই ওয়ালের ভেতর দিয়ে গিয়ে এই ওয়াল দিয়ে বাইরে বেরিয়ে আসতে হবে। So when those free electrons travel inside that cubical part, each free electrons will face an obstructive force by the material atoms of the conductor. যারা এই কিউবের ভেতরে যে সমস্ত অ্যাটমস আছে সেই অ্যাটমস গুলো কিন্তু ওই ইলেকট্রনস গুলোকে রেস্ট্রিক্ট করছে, অবস্ট্রাক্ট করার চেষ্টা করছে। যে কিউবিক্যাল পার্ট অফ দ্য কন্ডাক্টরকে আমরা কনসিডার করেছি তার লেন্থকে আমরা ইউনিট ধরেছি। in SI system it is 1 meter, আর তার ক্রস সেকশনটাকে আমরা 1 স্কয়ার মিটার যদি ধরি বা ইউনিট ক্রস সেকশন ইউনিট লেন্থ ধরেছি, এরকম ধরনের একটা কিউবিক্যাল পার্ট যদি আমরা কন্ডাক্টরে কনসিডার করি, দেন ওই যে কিউবিক্যাল পার্টের ওই যে কিউবিক্যাল পার্ট তার যে দুটো অপোজিট ওয়াল আছে, দিস ওয়াল অ্যান্ড দিস ওয়াল, এই দুটো অপোজিট ওয়ালের মাঝখানে যে resistance apply hobe against the flow of free electrons, that is called this rho, and it is called resistivity or specific resistance. So this is equal to the resistance applied by the opposite walls of a cubical piece of a conductor whose cross-sectional area is unit and length is unit. That means আমরা এমন একটা কিউব চুজ করেছি, কিউবিক্যাল পিস অফ দ্য কন্ডাক্টর চুজ করেছি যার লেন্থটাও ইউনিট, ক্রস সেকশনটাও ইউনিট। দ্যাট মিন্স এর volume is we know that volume is equal to cross section into length. That means 1 into 1, that means unit volume. ইউনিট ভলিউমের একটা পিস তার ভেতর দিয়ে যখন ফ্রি ইলেকট্রনসরা মুভ করবে, সেই ইউনিট ভলিউমের ভেতরে যে কনস্টিটিউটিং অ্যাটমস গুলো আছে তারা অবস্ট্রাক্ট করবে the motion of the free electrons, and that obstruction between the two opposite walls of that cubical piece against the flow of free electrons, that resistance is called specific resistance or resistivity. And its unit, you can derive the unit of rho. Resistance এর ইউনিট আমরা শিখেছিলাম ওম, and it is symbolized by this sign. This is omega. This is a Latin letter omega. So here is omega, and here is, if you take SI system and meter, 1 meter cancelled out, then ohm meter. This is the unit of resistivity. If you take CGS system, then it is ohm centimeter. So if you are given a certain statement that rho of a certain metal is 0.63 into 10 to the power minus 2 ohm meter, what does that mean? That means when free electrons start flowing through that conductor or made up of that metal, then the free electrons faces an obstruction of this ohm between two opposite walls of a cubical piece of the conductor whose length is 1 meter and cross section is 1 square meter.